Let us consider a static system whose input-output relations are given by this y is equal to mx. So this is a linear system. X is input, y is output. There is a linear relationship between x and y. Consider a system which is given by this y is equal to mx plus c. It is not a linear system, it is an affine system. Proof for this can be given like this: y1 is equal to, when x1 is the input, let output be y1. When x2 is input, let output be y2. When x1 plus x2 is input, let the output be y3, which is given by this. This is not equal to y1 plus y2, because y1 plus y2 we will get 2c, whereas it is only c here. So this is a special kind of system called affine system. For a system to be linear, the equation, it must pass through the origin. So since this has some intercept, some transformation is required to make it, to shift the axis and make it pass through origin. Consider a static nonlinear system y is equal to x. It is a static nonlinear system. So for such a system, intuition says that differentiation at a particular point or tangent at a particular point gives the linear approximation at that point. So at different points, slope will be different, and that is a linear approximation of that system or that equation. So consider a general system whose input-output relationship varies in this fashion. If we zoom this plot in small neighborhood delta x and delta y, if you zoom this plot in the small neighborhoods, if you zoom it appears to be a straight line passing through origin of this particular axis delta x and delta y. So at every point, the tangent gives the linear approximation around that neighborhood. So one can arrive at the same using Taylor series expansion. So consider for this system, select an operating point y0, x0 and y0. If we zoom the system's response around incremental variables, if we consider small perturbations around that operating point, we will get y0 plus delta y is equal to x0 plus delta x whole square. If we expand this, we will get like this. As delta x is very small, delta x square can be neglected. So delta y will be 2 delta x x0 or 2 x0 delta x. If you substitute a value of x0, this will become a constant. So delta y is equal to k into delta x. This looks in the form of y is equal to mx. But if we see, these are incremental changes. This is for a static system. Now for y is equal to x square, we have shown a method to find this constant k. That is, you have to find out the slope at a particular point. Say x is equal to 1, the slope is 2. So around that operating point at x is equal to 1, we will get the linear relationship is dy is equal to 2 dx. If x is equal to 2, dy is equal to 4. dy is equal to 4 dx. So at each operating point, the linear approximation changes. Suppose you have a general function f, which is non-linear function of x. So the linear approximation of f is delta f is equal to k times delta x. How to find this k is df by dx at that particular operating point will give the linear approximation around that operating point.